Hey guys, I'm moving on to chapter 4, and at the start of chapter 4, the Alkane chapter, or Alkanes, we have nomenclature, which is a new idea in organic chemistry. It's the naming of compounds, which you'll find in at least 10 or 11 or 12 chapters at different parts of alcohols, alkenes, alkynes, carboxylic acids. So a bunch of nomenclature. This is the general introduction of nomenclature. So the first thing in nomenclature is the parent chain. So parent chain right up here is the longest continuous chain of carbons. So I have an example right here of long hydrocarbon chain, which means there's only carbons and hydrogens. And all you have to do is basically figure out where the longest chain of carbons is. And if you do so, you get these names which coincide with how many carbons there are on the parent chain. So for example, right here, all we have to do in this molecule is find, how can we number this so we get the highest number? So one idea could be 1, 2, 3, 4, 5. But we also have more carbons up here. So let's try that. And let's see if we can get above 5. 1, 2, 3, 4, 5, 6. So that's the longest chain of carbons in this molecule. And if we have a parent chain that has 6 carbons, you look here, that has that's a hex or hexane. So that's the basis of parent chains. And then if you have this chain of carbons, let's say I'll highlight it like that. Whatever is not in that parent chain, you see there's this one group of carbon, that CH3 group, we call that a methyl group. That is called a substituent. Just a fancy term. Whatever's not on the parent chain is called a substituent, and the list of substituents are here. So number of carbon atoms in the substituent, that one we had right here, there was only one, so that would be a methyl group. Okay, and we'll get into numbering in a second. Let's try to find the parent chain in this next one right here. So this one, again, feel free to pause it if you want a little bit of time on this. I would start right here. So let's label that 1, 2, 3, 4, 5, 6, 7. That looks like it would be the longest chain of carbons we could do, because this would be 5, 6. We would only have 6 going that way. So we have 7 carbons in our parent chain. So 7 carbons would be heptane. Okay. This next one, 1, 2, 3, 4, 5, 6, 7, another heptane. And again, we have 2 substituents, 2 methyl substituents coming out there. All right, and then this next one, let's see what the longest amount of carbons we can. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe that's the longest chain of carbons we can do. And I'll go into why the numbering starts where it does, why it might change, stuff like that. So 9 as the parent chain is nonane. Okay, so pretty straightforward. This question up here asks to identify and name all the substituents in the following compound. So in order to do that, we really have to decide what our parent chain is. And this is a more, in-depth molecule. There's a lot of twists and turns, so it might take us a little bit to figure out, what's the longest strand of carbon. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can anything beat that? I don't think it can. So that is our parent chain. I will highlight that so we can really, see what our substituents are. So that's our parent chain. Oops. It's not the best highlighting. Let me get some better. There we go. That's pretty good. So now let's see what the names of our substituents are. Remember, you have the table right here. The substituents are not included in that parent chain. They're the branches out from it. So this first one right here, if we have one carbon coming out of our parent chain, that is a methyl group. That's a methyl. We have another methyl down here. Let's see, we have 1, 2, 3 carbons right here. So this substituent would coincide with a propyl group. And we have 1, 2 carbons right here. So that would be an ethyl group. You'll really only see substituents probably go up to butyl. It is possible to get pentyl, hexyl, but it's not as common as the first 4. So you really want to study these 4 names. And again, those names derive from this parent names of alkynes, right? So methyl or methane coincides with methyl. You just change the ANE to a YL for all of them. And if you think about it, we have alkane, and that ane in alkane coincides with the ane in everything else. So that will be something to look at, because when we get into alkynes, there's an ENE instead of an ANE. So there's a difference there, and those they change the names as well. So you'll get really good at this, the amount of practice you do of figuring out, if you have 5 carbons in your parent chain, well, that's a pentane. So going on, there's a bit of complex substituents that you guys will have to learn. They're not too hard. There's about 4 right here that I listed, and again, the usual substituents are right here. But these are the ones that are common in nature, and your book will probably want you to learn as well. So this first one, we have propyl. Remember, propyl is a 3-carbon substituent. So when you have 3 carbons and they're oriented in this pattern, so let's say we have our parent group. Let me just write out a molecule. This is our parent right here. An isopropyl will look like this. 3 carbons kind of branched out into a Y. It is called an isopropyl. And again, we'll learn how to bring all these names together to make one, molecule's nomenclature. And then butyl is a 4-carbon substituent. 4-carbon substituent. And there's 3 different types of butyl patterns, I guess you could say, or branches that you'll learn. You have sec-butyl, which is kind of just a 1 and then a 1, 2. You have isobutyl, which is the same as isopropyl, but you're just adding another carbon. So you still have this Y right here, but you just have this carbon. That's the difference. And then tert-butyl, which is just, if you look at a molecule, tert-butyl will look something like this. Okay, so those are some complex substituents that you'll definitely have to know for organic chemistry. Going on to numbering, I have a step-by-step guide right here on numbering. And we already did some of this, right? We already identified the parent chain. We already identified and named the substituents. We assigned, let's see, number the parent chain. We kind of numbered the parent chain. And then the last step, which we didn't do, is arrange the substituents alphabetically. So one big thing to note here is that, let's say we have this example here. Your substituents wants to be a lower number, and that's what it's saying right here. So your substituent, if you have multiple, this will be really clear. For this molecule, it would rather be a 2-carbon than a 6-carbon. So numbering is a factor in here. Let me just go through one quick example. Let's say we had this molecule with a substituent right there. Let's name or identify the parent chain, which is 1, 2, 3, 4, 5, 6, 7. So our parent chain is a heptane. We would want this to be a 2 instead of, if we did it the other way, it would be a 1, 2, 3, 4, 5, 6, 7. We would want this to be a 2 rather than a 6. So you want to assign your substituents the lowest number possible. It is what I'm trying to say. And then the last step here is to arrange the substituents alphabetically. So if you have, obviously this is a methyl group up here, and let's say we had, let me use a different color. Let's say right here we had a tert butyl. You would want to assign those names alphabetically. So M and T you would be looking at, and you would want to, in your naming, assign A, B, C, D, alphabetically. All right. So this is the first practice problem that I have here, is to provide the systematic name for the compound. So let's do it. Let's first identify the parent chain. So it looks like I'll start over here. So 1, 2, 3, 4, 5, 6, 7. So we have a parent chain that is 7. So that's a heptane. And it looks like we have 3 substituents coming out. So we have 1, 2, 3 substituents. Let's see how we would number this so that our substituents get the lowest number possible. You might think, oh, I'll just start over here because it doesn't matter where I start. Then our substituents would be 5, 6, and 7 carbons. But if we do it the other way, it'd be 1, 2, 3, 4, 5, 6, 7. Oh, I'm sorry, this is 8 carbons, so that's not heptane. It's octane. Then our carbons would have 2, 3, and 4. So that beats out the other way because now we have lower numbers. And now we can go about deciding how to name the rest of this compound. So we have a methyl group right here, another methyl right here, and we have an ethyl right here. So we named our substituents. Now we have to add this into our full nomenclature name. So where do these methyls show up? The 2-methyl and the 3-methyl, and we have a 4-ethyl. Okay. Oops. So I did that. One thing, a quick tip here, is when you have the same thing but different carbons, you can do 2-3, and that would be a dimethyl. Di means 2. Say you have a 2, 3, 4 methyl, that would be a trimethyl. So that's a good thing to note. So we have a 2,3 dimethyl, A, B, C, D, E. So D would be before E. We would have 4-ethyl octane. And there should be no spaces in here. It should be all connecting like that. So this is your name for this compound. 2,3-dimethyl 4-ethyl octane. We have our parent name right here. And we have our substituents right here. Okay. Let's name this compound. So let's do the same thing. Let's see what our parent chain is. We have 1, 2, 3, 4, 5, 6, 7. We can do this a couple different ways. We could do 5, 6, 7 right there as well. But I guess it doesn't matter which way you go. So I'll do this way. So our parent chain is a heptane. And we have 1, 2, 3 carbons of a substituent right here. So that's going to be a propyl. But if you guys recall, our complex substituents, if we have a Y look in propyl, that's an isopropyl. Okay. And then our other substituent right here is just a methyl. All right. So is our numbering correct is something we want to look at. If we did 1, 2, 3, that would be the same as the 1, 2, 3 here. I'm gonna write it the other way, just because that isopropyl is a bigger, substituent. It might have higher priority over that methyl. So I'm gonna label that a 3. So now we have 3 isopropyl, 5 methyl heptane. All right. And again, we're looking at our alphabetical letters here. I is before M, so we're good there. We have this compound. So let's again see what our parent chain is. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have octane. Let's see what our substituents are. Looks like we have 3 methyl groups. So again, this is methyl, methyl, and methyl. Is our numbering correct? I think it is, because this shows up at the 3 carbon. This would be 3 as well, so it doesn't really matter where we start. So we have a 3, 4, 6 trimethyl as our substituents. Whoops. And then octane for our parent. Hopefully this is starting to make sense. This is asking to draw the bond line drawing for each of the following compounds. So we went from compound to name. Now we're going from name to compound. So this is really testing you on, assigning names to everything. So let's start. The first thing I would do is go to your parent and draw that out. So that I'm going to be working on A here to start. So A's parent name is pentane. So I drew out 5 carbons, right? 1, 2, 3, 4, 5 to show that pentane. And then we can assign, if you guys want to assign numbers so you can know where those substituents should end up, you totally can. So on carbon 3 in our pentane, we should have an isopropyl. So I'll draw that. And then on 2 and 4, we should have methyl groups. And that is our compound. I'll draw it without those numbers as well. So that is going from the name to the compound. Okay, so that's for A. Let's look at B. Our let's see, our parent is a hexane, so that's 6 carbons. We have 1, 2, 3, 4, 5, 6. Let's look at the substituents. We have a 2-methyl. So on our 2, we should have a methyl. And on our 4, we should have an ethyl. So 2 carbons, F is ethyl. So on carbon 4, we should have 2 carbons branching out. And let me show that without the numbers. A methyl and an ethyl. Again, ethyl is 2 carbons, methyl 1, propyl 2, butyl, propyl 3, butyl 4. So that's that. For C, our final one, we have propane. So again, propyl is a 3-carbon substituent. Propane would be a 3-carbon parent. So it'd look something like that. All right, again, 1, 2, 3. On carbon 1, 1, 2, 2, we all have methyl groups. So again, if you have methyl groups, and I guess this one we have 4 of them, so that'd be tetra. Again, if you have 2 methyl groups, it'd be di. If you have 3, it'd be tri, and 4 is tetra. And it looks like we have 2 methyls. I'll draw them like this. 2 methyls on 1 and 2 methyls on 2. So without the numbering, it looks something like this. All right. Oh, that's a cyclo. Ooh, I almost caught it off guard. cyclo. So that cyclo means that it has to be a ring. So it would actually be a 3-membered ring. I'm glad I caught that because I was thinking, well, we would have more carbons in there. But it's cyclo, so that cyclo means it has to be a ring. If this was, let's say, cyclohexane, we would need 6 carbons in a ring. So I'm glad I caught that. So cyclopropane, we have 1, 2, 3 carbons, and then we have 2 methyls coming out of the first position and the second position. So what would that look like without the numbering? Something like that. I'm glad I caught that cycle. So that's it for this video. Hopefully that helped. Again, this takes a lot of practice and a lot of time and practice problems. So my next video will be about Newman projections. Again, we're continuing into chapter 4. So I'll see you guys in the next video.